Hey guys, I hope you enjoyed this math course. Now, I know there's a couple of issues with this particular math course, so I'm going to go over a little bit of the concepts that you need to know from grade 8 math to be prepared for the grade 9 math course. The first thing we're going to do is look over exponents. Now, when we do have the basic exponents and everything, this whole thing we refer to as our power. The A over here we call our base, and the B over here will be our exponent. Now, when you guys are looking into powers and exponents and everything, you have the exponent laws. The main ones that you need to know, the first one is known as the product law. The product law is when you have two powers multiplying with each other, and when the bases are the same, it's very important for the bases to be the same. If they're not the same, then we cannot use the product law. When the bases are the same, then you would add the exponents. So an example of that would be if I had 2 to the power of 3 times 2 to the power of 4. Now, as you could see, the bases over here are the same. So what I would be doing is adding the exponents. So it would look like 2 to the power of 3 plus 4, which is 2 to the power of 7. And another thing is, let's say there's a coefficient in front of the power. So if I had 2 to the power of 2 times 2 to the power of 4, I would then do 3 times 2 to the power of 2 plus 4, which will equal to 15 times 2 to the power of 6. So these are using numbers. We could also use variables in here as well. So we could have something like 7x to the power of 5 times, let's do negative 8x to the power of 3. So then we would do 7 times negative 8 x to the power of 5 plus 3, which equals to negative 56 x to the power of 8. And this is pretty much the general idea for your product law. The next one that we have is known as your quotient law. And this is when our bases are the same and the powers are dividing with each other. When the powers are dividing with each other, what you would then do is subtract the exponent. So it's pretty much the opposite of when the powers are multiplying with each other. So we could have something like 2 to the power of 8 divided by 2 to the power of 7, which will be 2 to the power of 8 minus 7, which is 2 to the power of 1. We do not need to write that 1 there, so we would just write down 2. I'll give you guys another example. You could have 18x to the power of 10 divided by 12x to the power of 7. What we would then do is simplify 18 over 12, and we would do x to the power of 10 minus 7. And when we do simplify that, we get 3 over 2 x to the power of 3. Now, if you're confused as to how I got this, I divided both of them by 6. and I simplified it, and that's how I got the answer. The next one that we will be looking at is called the power law. Now, the power law is when you have the power and there's exponent attached to it. So it would look something like this. And what you would do is multiply the exponents. So an example of that would be if you had 2 to the power of 2 to the power of 3, you would do 2 to the power of 2 times 3, which is 2 to the power of 6. And if you had a coefficient attached to it, so let's say 3x to the power of 2, y to the power of 5 to the power of 2, the exponent will be added to every single one of them. So it would look like 3 to the power of 2, x to the power of 2 times 2, y to the power of 5 times 2, which is equal to 9x to the power of 4, y to the power of 10. Now, a few basic things that you need to know is anything to the power of 0 will always equal to 1. So if I had 5 to the power of 0, this equals to 1. If I had x to the power of 0 equals to 1. If I had 278 x to the power of 4, y to the power of 5 to the power of 0, this equals to 1. The next thing that you need to know is when we have a negative exponent, we cannot solve for a negative exponent, so we would need to change it to positive. So it would look like 1 over a to the power of b. So when you do have a question like that, it could be something like 2 to the power of negative 3, which is 1 over 2 to the power of 3, which results to 1 over 8. Similarly, if I had 2 over 3 to the power of negative 2, the first thing that I want to do is switch the numerator and denominator. That will get rid of the negative. So it would look like 3 over 2 to the power of 2. And then I would apply the power rule, which is 3 to the power of 2, 2 to the power of 2, and then just evaluate for it. So that is pretty much all the things that you need to know for the exponents. The next thing that we will be looking into would be understanding the Pythagorean theorem. So in order for you guys to use the Pythagorean theorem, you need to make sure it is a right angle triangle. If it is not a right angle triangle, you cannot use the Pythagorean theorem. The next thing that you guys need to know is these two that I labeled as A and B are known as the adjacent sides. And the adjacent sides are the two sides of the triangle that form that 90 degrees. And opposite of that 90 degrees is C. It doesn't always have to be C, like these variables could interchange with each other, but this is usually how it's written. And C is referred to as the hypotenuse. Now, the fundamentals of the Pythagorean theorem, let me make it a little bit different so you guys are able to visualize exactly what's going on. So what happens is so let me draw another triangle. so you guys could see how it works. So when we do have the Pythagorean theorem, the main thing is to make squares for each one of the side length. Now that we have our square, as we labeled it over there, this is A, B, and C. What we then need to do is think of, well, how do we make the area of the square? We know that area of a square is the side length times the side length. So we have A times A. And if you refer back to the power laws, it will be A to the power of 2. Do the same thing over here. Area is B squared. Do same thing over here. Area is C squared. Now, what this tells us is if I were to get all of this and all of this, both of these together should fit in this big square. And that's pretty much what the Pythagorean theorem goes over, is you're looking at the area of the square formed by side length A and side length B, and then you're trying to put those two squares into the square formed by side length C. So that is why we have the formula A squared plus B squared equals C squared. Now, this particular formula is very important because it's going to go over pretty much all of the courses in high school for math. So you just need to make sure you understand the fundamentals of it. You won't always be seeing this particular formula, but the concept behind this formula you will need to understand. In addition to the Pythagorean theorem, you guys would also need to know how to calculate surface area, volume, area in general, perimeter, those type of things for different types of polygons. You guys could look over some formula sheets and everything to get how to do those. So those are the two main concepts that you need to know for grade 9 based on the grade 8 methods. So these are the two main things that you need to take into consideration. The next thing that you need to know is your bed mass. It's very important that you understand how to use bed mass. Now, as you guys should all know, B stands for brackets, E stands for the exponent, D is for division, M for multiplication, A for addition, S for subtraction. Now, when you only have division and multiplication, it doesn't matter which order you do it, but the best way to do it will be going from left to right. So if you had something like 2 times 4 divided by 8 times 3 times 4 divided by 2, we don't have to do this one first. It is possible for us to do this first. So we could actually do 8 divided by 8 times 3 times 4 divided by 2, which would be 1 times 3 times 4 divided by 2, 3 times 4 divided by 2, 12 divided by 2, which is equal to 6. Now, this particular solution will equal to the exact same solution if you were to do this part first, then this part, and then just go from left to right. So when division and multiplication is the only operations, it doesn't matter which one you do first. I would recommend going from left to right. The next one that we have is if addition and subtraction are there together. So let's say we had this. Now you don't have to do the addition first. You could, like if we had subtraction in the very first thing, you could have done that as well. So you have this over here. It is not necessary that you do this one first, this one second, and then put them together. You could just go left to right once again. So those are pretty much the main concepts that you need to know from grade 8 in order to be prepared for grade 9.